Welcome to Cambridge Chemistry channel with Sarvat Ahmed. Today I will discuss ATP paper May June 2142. Hydrated magnesium. Let's start. Hydrated magnesium sulfate has the formula magnesium sulfate dot XH2O. When hydrated magnesium sulfate is heated, it loses the water of crystallization to form anhydrous magnesium sulfate. This is hydrated. This is hydrated salt with water molecule, and when we heat this salt, water is going to evaporate and this will become anhydrous. The student does an experiment to find the value of X in magnesium sulfate hydrated salt. The student records the mass of crucible, add hydrated magnesium sulfate to the crucible and records the mass again. Record the mass of crucible. So add hydrated magnesium sulfate to the crucible. Now next mass is about hydrated magnesium sulfate along with crucible. Heats the crucible strongly, allows the crucible and contents to cool, and then records the mass again. Repeats 3 and 4 until the same mass is recorded twice. Uses the results to calculate the initial mass of magnesium sulfate and the final mass of magnesium sulfate after heating. Initial mass is before heating and final mass will be after heating. Suggest why a crucible is used instead of a glass beaker. Crucible is thermally stable, or you can say that glass beaker can break. Suggest why 3 and 4 are repeated until the same mass is recorded twice. To ensure reaction is completed. Several students do the same experiment with the different initial masses. The results are shown. So initial mass and final mass 0.25 and 0.48, 0.83. So subtract the final mass from the initial mass, so we get this is 0. By subtracting mass we get 0.27 and 1.04. Complete the table on the grid. Plot the final mass of magnesium sulfate against the mass of Complete the table on the grid. Plot the final mass of magnesium sulfate against the mass of water lost. This is the mass of water lost and this is the final mass of magnesium sulfate. On y-axis final mass of magnesium sulfate and along x-axis mass of water lost. So first mass is 0. Water lost is 0.27. This is 0.27. This is 0.3. 0 and this will be 0.27. 0.27 and final mass of magnesium sulfate is 0.25. So 0.25, this is 1 2 3 4 5 6 7 8 9 10. So this is 0.2520. This is 0.27 and 0.25. Next is 0.50 and 0.48. This is 0.50 and 0.48. 1 2 3 4. And next value is 0.67, 0.83, 0.67, 0.67 and 0.83. At 0.67, 0.8, and 0.83. So this is around about over here. And next point is 1.04 and 1. 1.04 and 1. And 1.30, 1.23, 1.30. This is 1.30 and 1.23, 1.23, and final is 1.53 and 1.46, 1.53, 1 point and 1.46, 1.46. Draw a circle around the anomalous result on your graph. This is the anomalous result, because if we must draw with scale, So I don't have scale, so like this. Suggest a reason for the anomalous result. Draw a straight line of best fit. Okay, suggest a reason for the anomalous value. Reaction was not completed, or you can say water is not completely lost, or water is not completely lost. Draw a straight fit line. In another experiment, the final mass of magnesium sulfate is 1.20 gram. Use your graph to determine the mass of water lost. So 1.20 gram. Use your graph to determine. So this is 1.20 and this is this is 1.20, round about 1.22 gram. Calculate the number of moles of water in your answer to 1. Water, mole of water is equal to 1.22 divided by 18. 1.22 divided by 18, this is equal to 0.067. 1.20 gram of magnesium contains 0.01 mole of magnesium sulfate. Calculate the value of X in magnesium sulfate and water. Magnesium sulfate 0.01, this is 0.067. This is smallest divided by 0.01 is equal to 6 point, this is 1 and this is 6.7, that is approximately 7. So the X value is 7. A solution contains 2 different cations and 1 anions. Aqueous sodium hydroxide to the solution in a boiling tube. Pale green precipitate forms. Iron 2 ions. A green precipitate dissolves to form a green solution. The same boiling tube continue adding aqueous sodium hydroxide until in excess. So green precipitate dissolves to form a green solution. This will be chromium. So it is not iron 2. So his not answer is not required in this box. So cation 1 is chromium 3 positive. A white precipitate remains. Green precipitate dissolves to form a solution. So keep the content of the boiling tube for test 2 until in excess a white precipitate remains. So this is chromium 3 positive, white precipitate remains. It can be calcium 2 positive. Anion is nitrate, and add sodium hydroxide plus aluminum foil plus form the solution. So a gas with pungent smell is produced which turns damp red litmus paper blue. We have 3 cations, white precipitate, so aluminium, like aluminium 3 positive, zinc 2 positive, and lead 2 positive. They all form colorless solution with excess of sodium hydroxide, except calcium. Next question, B part is ammonium sulfate is a water soluble compound. Aqueous ammonium sulfate is slowly oxidized by oxygen in air. This means aqueous ammonium sulfate will also contain some sulfate ions. Describe a series of tests and observations to show the presence of ammonium ion, sulfite ion, and sulfate ions in this solution. It must be clear in your answer which ion is identified by each test. So ammonium ions, sulfite ions, and sulfate ion. Test of ammonium ion. And aqueous sodium hydroxide and plus form the solution. Observation: pungent smell is produced, turns damp red litmus paper blue. Test of sulfate ion. Add dilute HNO3 plus barium nitrate. aqueous. Observation: white precipitate of barium sulfate. Test of sulfitine and dilute acid HNO3. Observation: choking smell gas sulfur dioxide is produced, which turns acidified potassium manganate solution from purple to colorless. A titration method can be used to make soluble salt. A student does an experiment to prepare a pure sample of sodium chloride. Part of the method is shown in the diagram. Step 1, Step 2 and Step 3. Step 4 and rest of method. State how the accuracy of the experiment could be improved in Step 1. Use pipette instead of measuring cylinder. Describe what student does in Step 2. Include the names of apparatus A and B. Apparatus A is burette and B is beaker. Student fills the apparatus A fill the apparatus A with dilute hydrochloric acid by using funnel from beaker. Identify what is added to the flask in Step 3 before starting the solution. Step 3. Indicator is added in Step 3. In Step 4, the student adds solution B to the aqueous sodium hydroxide in the conical flask until the endpoint is reached. The student records the volume of solution B added. State how the student knows when the solution in flask changes the color. The rest of the method involves adding the recorded volume of solution B to another 25 centimeter of cube of aqueous sodium hydroxide. The student adds in step 3 of the first iteration is not added. State why this substance is in step 3 indicator is not added. Why this substance is not added? To prepare pure sodium chloride. Describe how the student obtains pure crystals of sodium chloride from the solution in the conical flask. Heat the sodium chloride solution till saturation point. Allow the crystals to cool and dry in 3 folds of filter paper. A student oxidizes a sample of ethanol. Some of the apparatus the student chooses is shown. That says Liebig condenser, Q is the round bottom flask, and R is filter funnel. The student transfers 25 centimeter cube of ethanol into apparatus Q, add an oxidizing agent, assemble the apparatus as shown. Heats apparatus Q gently until all the oxidizing agent has changed color. Name a suitable piece of apparatus to measure 25 centimeter cube of ethanol. 25 centimeter cube of ethanol, this is pipette. Name a suitable oxidizing agent. Potassium manganate 7. State the color change that would be seen with this oxidizing agent from purple to colorless. Suggest a reason for placing apparatus P vertically. Prevent vapor escaping from the flask. After all the oxidizing agent reacts, apparatus Q contains a mixture of ethanol, water and the products of oxidation. Name the product of the oxidation. Ethanol is oxidized to form ethanoic acid. Name the process used to separate the 3 liquids in the apparatus Q. So this is apparatus Q contain ethanol, water, these are the miscible, and ethanoic acid. miscible liquids, and to separate these three liquids by using fractional distillation on their boiling point. So fractional distillation, like the liquids with lower boiling point distills over first, and afterwards the liquid with higher and then higher. State why this process is suitable. You should refer to a physical property of the liquids. Different boiling points. The apparatus shown is used to complete the rates of reaction of different metals with hydrochloric acid. The student places a sample of one of the metals in a small test tube. Transfer 50 centimeter cube of 0.100 mole per dm cube hydrochloric acid in the conical flask. Places the small tube into the apparatus as shown in the diagram. Tips the flask so that small tube falls over and the metals and acid come in contact. Into contact. Starts timer. Record the total volume of the gas formed at a regular interval until the reaction finishes. Repeats the method with each metals. So these metals are given, and we use all metals uh, to find out the speed of reaction by using this apparatus. So the name an alternative piece of apparatus that could be used instead of measuring cylinder to collect the gas and measure its volume. Gas syringe. The gas collected in the measuring cylinder is hydrogen. Give a test. Take a lighted splint near the gas jar. Hydrogen produces, pops in flame with lighted splint. Another student thinks it would be easier to remove the bung from the flask, add the metal directly to the acid and then replace the bung. State two disadvantage of this method compared with the one described. Hydrogen will escape, and bung will displace gas into measuring cylinder. A graph representing the results is shown. Give the correct labels for each axis of the graph. X-axis the time, while along y-axis volume measured in centimeter cube. State y curve A starts steep, gradually levels off and then becomes horizontal. Steeper the graph, faster the rate of reaction. And levels off means reaction slow down. Horizontal lines mean reaction is stopped. A reaction stops. Identify which of the metals gives each of the curves A, B, C, D. 0.080, 0.100, 0.048 and 0.130. A is calcium because it is more reactive, B is magnesium, and C is zinc, and D is iron. Identify which of the metals gives each of the curves A, B, C, D. A is calcium, B is magnesium, zinc, and iron. Different masses of each metals are used for 4 experiments. State 3 variables that must be kept constant for the experiments. Concentration of acid, temperature, and surface area of metal. Suggest why different masses of each metal are used for 4 experiments. State why different masses of each metals to give the same number of moles of each, because when we calculate 0.08 over 40 over 56 over 24 over 65, we get same moles. 0.080 divided by 40 is equal to 0.02, and similarly 0.112 divided by 56 is equal to 0.002. This is again 0.002, 0.002. So why the different masses of each of the metals are used for 4 experiments to have same number of moles. So this is all about of the paper. If you like this video, please subscribe this channel, and if you have any query you can ask in the comment box.